Welcome to Submodule 1.2, Types of Geothermal Systems and Principle of Heat Transfer. In this presentation, we'll talk about both open-loop and closed-loop systems and consider the heat transport in both those systems. To start with open-loop systems, the general principles are that we extract groundwater from a groundwater well, and usually through a plate heat exchanger, we can exchange thermal energy with the building system, which usually consists of a heat pump and can also use passive cooling, of course. So in summer, when there is a cooling demand, the building will use the water from the ground to cool the building, heating the groundwater up, and the warmer water is injected into the warm well, which we can see on the left. In winter, when the building has a heating demand, we can switch the wells, we can extract water from the warm well, use that to heat up the building. Heat is being extracted from the groundwater and the cool water is re-injected into the ground, creating a cold well. So the transport of energy is basically by pumping groundwater around through the ground and the aquifer and exchanging energy with the building due to a temperature difference over the plate heat exchanger. If we have a warm and cold well in a storage system, then we have a very high storage potential and a very high thermal capacity. What is very essential for this system is aquifer quality. This has to do with the ease of pumping the water up and re-injecting it, but also the lifespan of the system, which is, for instance, affected by clogging of the wells due to chemical, geochemical, or geobiological processes, and those can be disturbed by the pumping around of the groundwater, for instance, by mixing of different groundwater qualities or by changes in temperature and pressure. Therefore, these systems in general have a high maintenance and high management. High operational management is required for the proper operation of these systems. Now, a doublet with two wells where we use one as a heat store and one as a cold store is a relatively complicated system. Easier or more simple systems are also possible. For instance, a mono well where we not have two wells but one well, and we can still have storage where you can see this in the left picture. A cold well is created on the bottom and a warm well on the top if the aquifer thickness allows this. Obviously, when you have a mono well, you only have one borehole, one set of pumps, and one set of heat exchangers and everything. So it's much more simple and it is more compact. In a recirculation system, we still have two wells only. We have one well where we pump the water from and another well where we inject the water in, and we don't change this over seasonally. We keep pumping from the same well and injecting in the same well irrespective of the season. This we can do, for instance, if we have a high groundwater flow, which would remove the stored heat and cool from the wells. Again, because we only have one pump and one injection system, it is a cheaper system to realize and easier to manage. So mono well or recirculation. Here we can take a look at how those systems will operate in practice with regard to capacity and temperature. A doublet has either a storage or a recirculation system, has a very high capacity. Each well can have up to 250 meters cubed per hour. A mono well has a limited capacity up to 60 cubic meters per hour. And then, of course, the thermal capacity will be limited in relation to that limited volume of water flow. The temperature, of course, depends on the location and usage. You will have much higher water temperatures in South Europe and much lower water temperatures in Northern Europe. In the Middle Europe, let's say the Netherlands, we have an average temperature of around 12 degrees in the ground. And then if we look at a graph of a storage system with a warm well and a cold well, which we can see in the graph on the right over the years, we get a kind of block graph where in winter we extract warm water from the warm well to use for heating and re-injecting this at low temperature in the cold well. So we're extracting water at, let's say, 15 degrees and then re-injecting it at around 7. And then in summer we switch over and we start extracting water at a low temperature, 7.5 degrees or something like that, to use for cooling in the building. So we get a very high efficiency due to the fact that we have a relatively high temperature during heating operation and a relatively low temperature during cooling operation. For a recirculation system, the straight line in this graph, we anticipate a constant groundwater temperature, so no recirculation between the wells, no thermal interaction between the wells, and we extract water at a constant temperature. So with these systems, we can do heating and cooling using the heat pumps, and also passive cooling is possible if the temperature in the ground is low enough.